Lilensten, who will present the 20th anniversary lecture of Space Weather Week.
Thank you very much. I want first to thank the Executive Board and the European Space Weather Week Program Committee for inviting me to give this talk. It's a big honor, and I was proposed to browse the last 2 decades. That's also how I understand that I am getting old in space weather. So I will present the last 20 years indeed. I decided that I would not show any scientific plots. Almost all the illustrations of this presentation are coming from the people we call amateurs, and I call them astrophotographers. When I prepared this lecture, I realized that I could not say everything that happened during the 2 last decades, and I will only give some milestones. I cannot be exhaustive. I also wanted to cite all the friends that participated to all the actions, and I started to write a big list of names, and I stopped when I reached 100. So I decided not to cite anyone because there are too many people, but many of them are in this room, and I want to thank them very, very much. Before I start with the last 2 decades, I have to go back in the 80s, in the 90s for the premises, because we had amusing questions at that time, like, is there something called space weather? Does that really exist? And is there really worth a space program? Is there impact? And are industry people interested in space weather? Or is it just a new dream, a new way to get money from funding agencies? Is there even a scientific community? But as all of you know, there was this big event in Quebec in '89, and the first to react was the US. The already existing Space Environment Service Center started to issue structured alerts and forecasts after this event. It was based in Boulder, Colorado, and had already very strong links with research at NCAR HAO. I had the chance to be a postdoc there at that time, and I started to work with Barbara Emery, Ray Robel, and Art Richmond on building a first thermosphere-ionosphere global circulation model. And those people were really in advance. In parallel, people in the US had already started to write an ionospheric model. It was called actually the Incoherent Scatter Radar Model, IRI. And it was under the COSPAR umbrella. And, but it became operational after this big event. For the magnetosphere, we had the Tsiganenko model and MSIS, the first atmospheric model. And again, after these big events, all those models started to become operational. A very important step is that the US Air Force recognized the need for a dedicated team to monitor and forecast space weather. That was very important because it created the Space Weather Operational Center. We know very little about China and Russia. We know that they were also interested, but I have very few informations. And the US also started to coordinate the international effort, at least through 2 different programs. One was the ISTP, International Solar Terrestrial Program, and another one was Living with a Star, which became soon the International Living with a Star. A few years later, the International Space Environment Service was formally created. Actually, it was not created from scratch, and the effort dates back in 1928. But the kick was after the International Geophysical Year in '59. But in '96, ISES was created with actually 10 cities only, 10 centers. There was, in 96, the first meeting fully devoted to space weather was created in the US. It was the Space Weather Workshop, and we used to call it the Space Weather Week. It was under NOAA's umbrella. All those pictures are taken from ground and from the Earth, and including this GIF movie. The number of regional warning centers started to increase in different countries in Europe, and Belgium played a very particular role. I had the chance to meet with Belgian people from the government. They had this idea, thanks to Belgian colleagues, that space weather could become a niche where Belgium could get a leading role. And the SIDC expanded its scope from just sunspot counting to space weather monitoring and forecasting in 2000. And the Sunspot Index Data Center, SIDC, became the Solar Influence Data Analysis Center, SIDC. And they started to deliver the first European 24-hour, 7 days a week service. In the late 90s, ESA produced a call, and the basics of the call was, is it worth to spend money on a space weather program? And it turned out that two big consortia answered to the call. It was not possible to rule any of them. I was belonging to one of them, and so ESA decided to keep the two consortia and to create a coordination body, which was called the Space Weather Working Team. The conclusions were that launching a full space program devoted to space weather was premature. We needed to structure the scientific community, we needed to coordinate efforts, we needed also to know more about the needs of industry, and the Space Weather Working Team became a permanent ESA advisory board. Following the conclusions of those consortia, ESA launched the Space Weather Program to fund research and to build infrastructure to monitor space weather and the effects. And that was a very important step in Europe because we had funded pilot projects. So that's the end of the premises, and now I can start with chapter 2. You see, the questions were not so funny anymore. We had now serious questions, and the questions were, can we better define space weather and actually space climate that had totally been forgotten before? And actually, who are we? I remember that during our workshops, we had very strong arguments against each other to define who we were. Were we doing operational things or science and so on? And we were also wondering where Europe would fit and how to organize the community. We already had many instruments in space. Of course, the European Space Agency and NASA had launched SOHO, and you all know about it, but NASA actually had a fleet of instruments in space, like ACE and WIND and POLAR, and GOES with NOAA. But at the European Space Agency, we also had the cluster satellites, which were a milestone. The Russians, they launched Interball, and in Japan, we had Geotail. We had, at that time, 4 incoherent scatter radar. IceCat, the only one tristatic, able to see the same volume in the sky from 3 different points, Arecibo, Chicamarca, and Thunderstrom. We had already coherent radar, SuperDAN, and we had a fleet of magnetometers. I could not find the exact number, so I wrote 150 to 200. And we had already several ground optical observatories. And in 2003, we had this Halloween Storm series. So this is not from astrophotographers. This is from SOHO. This series of events happened more than 2 years after the solar maximum. We should not call it solar maximum. It is confusing. It is just a flip of the magnetic field. It does not mean that the activity will be maximum at that time. So it was 2 years after this flip. And in the US, NOAA issued more than 250 alerts. That was the first time, so it was very interesting. Look, here on the left, you can see an all-sky camera during one of those storms in November. And it was the best quality of all-sky cameras at that time. It was given to me by Thomas Ulisch from Finland. Of course, there were many impacts, GICs and system failures and blackouts and warnings for the ISS. For the first time, we had actions to deroute airlines, and so we could realize how expensive it is. It's derouting a flight costs about between $10,000 to $100,000. Many anomalies were reported in spacecrafts, but what we know the best are the scientific spacecrafts. Almost 60% of them were impacted, and one was lost. But, excuse me, one important thing is that all over the world, the media started to be interested in space weather. The Soho pictures were published in tens of countries. And that was a real turn. However, at that time, we lacked reliable and easy-to-get warning alerts and procedures. For example, in October, I led the kickoff meeting of Cost Action. I will come back on it later. And immediately after, I went to IceCat to run an experiment, and IceCat was in maintenance. And I said to the staff, stop immediately the maintenance and let's monitor, let's make measurements. And the staff said, we have no procedure for that. We cannot do it. That's how I missed the 3rd of November storm at IceCat. So you see, we were not able to stop something just because an alert was coming. Again, the US reacted very rapidly. The American Geophysical Union launched the Journal of Space Weather in 2003. Of course, it had been prepared ways in advance, but it turns out that after this Halloween storm, it was launched. And the Coordinated Community Modeling Center became a very important hub for developing and coordinating the models of space weather. And maybe very important again, the 2nd Space Weather Squadron was activated as part of the Air Force Space Command, so a very high level. Oh, I love this picture. Actually, this picture is Mars rising behind the moon, as seen from the Earth. Okay, in Europe, we are not slower. We must be proud of what we are. But we have tens of armies, we have tens of languages, we have scattered administrations, we have several national space agencies, and the European Union is permanently in constriction. So I consider it as a strength, but of course it obliges us to move more slowly. In 2003, between 2003 and 2012, we had 2 coordinating European actions. They are called Cost Action. It gathered 24 countries and more than 200 researchers. And from these 2 actions, several initiatives were taken. In 2004, we created the first European Space Weather Week. I think that we were wrong. It should have been the European Space Weather and Space Climate Week, but we were premature. So I take it on my shoulders. It's my fault, and not yours. I believe that we should have been more mature. We worked a lot so we had the ground to meet each other. And then we worked a lot to define what is space weather and what is space climate. And we came with a good definition of space weather and space climate in 2006. So we knew who we are. And then we decided to create the first open access journal of space weather and space climate. And Jürgen reported about it. It was in 2010. And a few years later, because we we, many in this room and myself, we thought, okay, now we are a mature discipline. We are able to honor some of us, and we created a set of medals that Andrea reported on. In parallel, ESA was a very, very active actor, and ESA created the Space Situational Awareness Program. Space Weather was part of it. ESA also created the Space Weather Coordination Center, and it became the ESA Space Weather Service Network, and with multiple centers of expertise, service development teams, data providers across Europe, and it was aiming at delivering real-time data, forecasts, and alerts. More space weather centers started in Europe, in Spain, Italy, Greece. I'm sure I will forget some of your countries. Please forgive me. In Norway, in Sweden, Finland, and so on. In UK, of course, UK was very active as well. And gradually we saw more private companies joining the European Space Weather Week. The original sunspot section of SIDC becomes a sunspot index and long-term solar observations. And SIDC got deeper and deeper in making forecasting, bulletin alerts, and so on. And Met Office started a 24-hour, 7 days a week staffed operation in 2014. But the dynamics is worldwide, of course, not only in Europe. And the NOAA Space Weather Prediction Service became the Space Weather Prediction Center in 2007. We had, again, new actors everywhere in the world, in Australia, Japan, South Africa, and so on. Again, we know that there is a big space weather center in China, one in Russia, but it's difficult to have many information on them. We also had more instruments like Discover, and of course the Parker Solar Probe and Solar Orbiter, and SWARM and Proba2. So in space we had much more instruments, and the GNSS constellation started to be used to measure the tech. IceCat became IceCat 3D, and we have more optical ground observatory. We have more magnetometers, and so we have now more instruments than 20 years ago. We also saw that the artificial intelligence started to grow and to become very important. There are now more than 300 journals devoted to artificial intelligence and machine learning. Of course, not 300 in space weather. And there are dedicated tenders from all funding agencies, including for space weather. We have more numerical global models, and the models that were already existing were improved, and they were all improved thanks to an international collaboration. So SolarWind, Enlil in the US and Euphoria in Europe. We have radiation belt models. The Tsiganenko model was improved, but there are others. The ionosphere IRI now is, of course, the international reference ionosphere, and no longer the incoherent scatter radar ionosphere. And we have several thermosphere models. In 2022, after 3 years of discussion, we created E-SWAN. That's when we signed the final agreement. It was created, and it became immediately, you are here, it became the largest body for space weather and space climate. And it was very important because it means that now in Europe we are as stable as a tripod. We have the European Union, we have ESA, and we have E-SWAN. And that's a very stable structure. So in 2024, we have a seasoned and ready communities that know each other well. We have numerous instruments, a wealth of forecasters and forecasts, an industry which is more aware. And as I show, we have also astrophotographers. Out of my 3 last papers, 2 are based on astrophotographers' work. And then a few months ago, we had this Mother Day event. And we were much more mature than 20 years ago. Warnings were issued in more than 15 countries. And they were issued including to all public, to any kind of publics. We had medias involved and conferences in many, many countries. We had also artists working on interpreting what they were showing. So that's how a musician interpreted the solar wind the 10th of May. And yes, and look, this is on the left side, this is an amateur all-sky camera in France. And on the right side, it's a professional one in Shibotten, in the field station from the University of Tromsø. Yeah, and that's during that night of the 10th of May. So you can see the difference between the all-sky camera we had 20 years before. That's just totally incredible. And that's from another astrophotographer. That's a movie, so it should be a movie. Yes, here it is. This astrophotographer in the room, that's from the Alps in France, and you can see the quality that is reachable now to monitor space weather events. So I will now conclude very soon, and the questions become actually much more serious than before. I will retire soon, so I dare to speak very seriously. I spent part of my life, again, with many friends in this room. I spent part of my life to build the European frame of space weather and space climate. And of course, we did our best, but it needs constant improvements. And we have a new context. And I will ask a few questions. I have no answer. I have no lesson to give. I probably forgot some of those questions. But I believe that if we, or if you, because I will retire, if you do not ask yourself those questions, you are in a risk actually to die as a discipline and to let others answer on behalf of you. There are wars now everywhere. Not everywhere, but there are very, very many, much more wars than 20 years ago. And we start to hear about World War III. That's something very important. Where do we stand? You see, during the Cold War, there was this pugwash movement. The pugwash movement maintained a link between scientists from the two blocs, and they got the Nobel Prize. We have to decide where we want to stand. When Russia attacked Ukraine, we, a group, decided not to work with the Russian Academy of Science anymore. But where are the Russians now? I believe that there is no colleague from Russia in this room. We have to think about it. Where do we stand in the frame of this war, these wars in plural, and maybe the threat of a new world war? We have also to decide where we stand in front of the climate change. Are we victims or are we actors of the climate change? The solar activity is not responsible for climate change. Why aren't we more active? Soon is in a few years from now, I am absolutely certain that we will be called to account. We must be able to answer the question to the people, what we did against climate change. For example, how many space flights we can allow ourselves? Should we pursue a race toward more technology and more instruments? Of course, maybe it's yes, but then we have to justify it. We also have to think a lot about artificial intelligence. In 5 years from now, the estimation is that artificial intelligence will use as much electricity as Belgium or Argentina or Norway. So it will be difficult to sustain. We have to think about it. Do we need artificial intelligence? If the answer is yes, we need to know why and to be able to answer why it was very important. This is from my village, a SpaceX, a disgusting SpaceX in the sky with the comet and the Starlinks, and that raises the question of the nanosats. We are polluting the space environment with nanosats. Is it indispensable? Is it a must for space weather? Or can we get rid of them? If it is a must, we have to justify it soon. And we also have to decide what kind of communication tool we want to use. We now use tools that belong to GAFAMs. And if we let the GAFAMs provide the tools that we are using, then we will let them take power on us. The question of how to raise awareness was always present, but now we have to think on how to raise awareness without enhancing fear. Dominique already showed some actions. We took also an action a few weeks ago to name the storms. I will now conclude. At the end of the 18th century, there were two German brothers that illuminated the world. The elder was a philosopher, the younger was a scientist. He invented the idea of nature as we understand it today. Nature, something to be monitored, to be understood, not to be afraid of. So the elder, Wilhelm von Humboldt, wrote the following sentence to his brothers, Alexander, at the end of their lives. We had to realize that the true purpose of our efforts was not the cosmos, but simply the other. So now that I will retire and gradually disappear from this community, I wonder if space weather and space climate will be mature enough to reach this conclusion. Thank you very much.